Hello everyone, this is Dr.S.Shalini, Associate Professor, Department of Physics, RMD Engineering College. We'll now look into the Schrodinger wave equation, particle in one-dimensional box from the third unit quantum physics. Here, the particle is present in a one-dimensional box. So we have the particle in the region 2. Region 1 and region 3 or the particle or outside the box. We have the free particle that is within the box. Here the potential energy is same everywhere, that is V equal to 0. And outside the box and on the walls of the box, the potential energy is infinity. We have the boundary value given by V of x is equal to 0 for 0 less than x less than a, and V of x is equal to infinity for 0 greater than or equal to x greater than or equal to a. That is, the value of x lies between 0 and a. We have the wave equation given by d square psi by dx square plus 2m by h cross square E minus V into psi of x is equal to 0. Since the potential energy V is equal to 0, we get the first equation as d square psi by dx square plus 2m by h cross square into E psi of x is equal to 0. Let us take the value of 2me by h cross square as a constant k square. So k square is equal to 2me by h cross square. The general solution of the second order differential equation, that is the equation 2, is given by psi of x is equal to a sin kx plus b cos kx. We will now apply the boundary conditions, that is at x is equal to 0, psi of x is equal to 0. Our fourth equation becomes 0 is equal to a sin 0 plus b cos 0, that is equal to 0 plus b. So we get the value of b to be equal to 0. Now let us apply the value of b to be equal to 0 in equation 4. We get psi of x is equal to a sin kx. Let us move into the second condition. At x is equal to a, psi of x is equal to 0. So the equation 4 becomes 0 is equal to k sin ka plus b cos ka. Since the value of b equal to 0, we get 0 is equal to a sin ka. We have already obtained the arbitrary constant b to be equal to 0. So the other constant a cannot be equal to 0. So the only possibility is reducing equation 6 to sin ka equal to 0. Already it is known the value of sin n pi is equal to 0. Here n is a positive integer and it can take values like 1, 2 and 3. We get k square is equal to n square pi square by a square. So from equation 3 again we have the value of k square to be equal to 2me by h cross square. Let us now move into the value of h cross, which is equal to h by 2 pi, and that is the reduced Planck's constant. As we equate equation 3 and 9, we get the value of k square is equal to 8 pi square me by h square. On substitution, we get the value of E to be equal to n square h square by 8 ma square. E represents the eigenvalue, that is, we will be able to determine the energy of the particle. From equation 8 and 11, for each value of n there is a wave function and the corresponding energy level. En represents the energy eigenvalue and psi n represents the wave function. From equation 11, the first orbit energy can be quantized by substituting the value of n is equal to 1. So we obtain E1 is equal to h square by 8 ma square. In the general way, we can obtain n is equal to 2, which is 4h square by 8 ma square. For n is equal to 3, 9h square by 8 ma square. N is equal to 4, 16h square by 8 ma square. We can generalize this equation to be En is equal to n square E1. We can also write the value of E2 to be 4E1, E3 to be 9E1 and E4 to be 16E1. We have the energy levels for n is equal to 1, 2, 3 and 4. P is equal to integral 0 to a modulus psi the whole square into dx is equal to 1. We have already obtained the value of psi of x is equal to a sine n by x by a. On substituting to the previous equation, the value of psi square is a square sine square n by x by a. So we get integral 0 to a square sine square n by x by a into dx is equal to 1. We have the value of sine square theta is equal to 1 minus cos 2 theta by 2. Which on substitution and further simplification, we get the value of a to be equal to square root of 2 by a. Here we get 1 minus cos 2 n by x by a on substitution with the formula. That on integration gives the value sin 2 n by x by a. It is known sin n pi is equal to 0. Obviously sin 2 n pi is equal to 0. So the equation gets reduced and we get the value of a to be equal to square root of 2 by a. On substitution of the value of a, we get psi n of x is equal to square root of 2 by a sin n pi x by a.